Hi, this is Kate, and we're talking about rate. Which purchase of juice do you think is the best deal? And here we're focusing on the most juice for our money, not paying attention to what kind it is. Do you think we get the best deal buying 64 ounces for $3.95, 46 ounces for $2.99, or 20 ounces for $2.19? It may be helpful to have a calculator handy. The best deal is A. Maybe you just went with a gut feeling, but there's a way to compare numbers directly. Since they're all different sizes, it would be helpful to compare how much 1 ounce costs by dividing. We can see that choice A is the cheapest at 6 cents per ounce. What we're comparing here is the unit rate, the cost of one thing, in this case 1 ounce. Whenever you see the word unit in math or science especially, it's referring to one of something. We got that by dividing how much it cost by how many ounces. A vintage Formula One car completed a 162-mile Grand Prix track in 1.88 hours. A modern high-performance motorcycle completes a 38-mile track in 0.43 hours. Can you figure out which one had the faster average speed? The motorcycle is slightly faster. Again, we want to compare unit rates, how far each travels in 1 hour. By dividing distance and time, we can see that the car traveled an average of 86 miles an hour, and the motorcycle 88 miles an hour. Speed is also a unit rate. The distance traveled in 1 unit of time, in this case 1 hour. In this case, rate is distance divided by time. If you ride a bike 3 miles in 15 minutes, what is your speed in miles per hour? Remember that rate is distance divided by time. And be careful here because the time is given in minutes and the answer is in miles per hour, so you'll have to decide how to deal with that. The cyclist would be traveling an average of 12 miles per hour. We want to divide distance by time, but to get our answer in miles per hour, we need to change 15 minutes into a quarter hour, or 0.25 hours. 3 divided by 0.25 is 12 miles per hour. You take one car trip going 60 miles per hour for 2 hours, and another going 45 miles per hour for 2.5 hours. In which trip do you travel farther? The first trip takes you the farther distance. If we go 60 miles every hour for 2 hours, we end up going 120 miles. It makes perfect sense to multiply the 60 and the 2. Therefore, it also makes sense to multiply 45 and 2.5 to determine the second trip takes us 112.5 miles. A formula that's easy to remember and use is distance equals rate times time. Notice this is the same formula we have been working with. Distance equals rate times time, so d equals rt. If we divide both sides by t, well, t divided by t is really just a fancy way to write 1. So this formula is really the same one we've been working with all along. Rate equals distance divided by time. Let's see if you've really got this and can apply it to a new problem. A runner sets out on a 12-mile run. He knows his average running speed is 8 miles an hour. How much time can he expect this run to take him? The run should take about 1.5 hours. Distance equals rate times time. The distance is 12 miles and the rate is 8 miles per hour. To solve for t, we should divide both sides by 8. So t is 12 divided by 8, or 1.5 hours. Since the speed was given in miles per hour and the answer is in hours, there's no need to convert hours to minutes or back. Understanding rate can make it useful to solve more complicated problems than just calculating distances and times. For example, if we know Alice can eat a bowl of popcorn in 6 minutes, and Claire can eat the same amount 2 times faster, that means she can eat 1 bowl in 3 minutes. How much time will it take them to eat one bowl of popcorn together? Let's think about what will make sense as an answer to this question. How much time will it take for them to eat one bowl of popcorn together? What kind of answer do you think makes sense? Should it take them 9 minutes to get through one bowl? Something longer than 6 minutes? Less than 3 minutes? Or somewhere between 3 and 6 minutes? Since Claire can polish off a bowl by herself in 3 minutes, if Alice is helping her, it's going to take less than 3 minutes for them to eat one bowl together. So how can we figure out the time exactly? We'll have to combine their rates together. Each girl's unit rate would be how much popcorn divided by time. This will tell us how much popcorn they can eat in 1 minute. Alice can eat 1/6 of a bowl every minute, and Claire can eat 1/3 of a bowl every minute. If we add these together, we have to get the same denominator and then keep the denominator and add the numerators. We get that they eat 3/6 or 1/2 of a bowl in 1 minute if they're working together. This means it will take them 2 minutes to eat one bowl. Now you'll try one, but don't worry, I'll help you every step of the way. A comic book author needs to print 900 books. WePrint can print them in 15 days, and Publish You can do it in 10 days. How many days will it take if both shops are working at the same time? If they work together, what kind of answer makes sense? Publish You would take 10 days by itself. So if WePrint is also printing, it must take less than 10 days to print the 900 books. Let's keep in mind that our final answer should be less than 10 days. Once again, we'll work with their rates of production. How many books can WePrint make in 1 day? "60 books. 900 books over 15 days means that they are printing 60 books a day. How many books can Publish You make in 1 day? "90 books. 900 books over 10 days means 90 books per day. So if they are working together, how many books can they print in 1 day? They can print 150 books a day by adding 60 and 90. And now for the big finale. Keeping in mind that the amount produced will be the rate multiplied by time, how long will it take them to print 900 books? It will take them 6 days. Amount equals rate times time. So 900 is 150 times t. Divide both sides by 150. And 900 divided by 150 is 6 days. This is supported by our earlier reasoning that the answer should be less than 10 days. This is Kate, and you've been working on rate problems.